Today we're gonna make sure we know how to factor expressions that have degrees higher than 2 and 3. We've used already the strategy for factoring by grouping, but we're only used to factoring by grouping when the degree is 3 or less. So now I'm just going to run through 3 different examples of what strategies you might already know about to use to factor an expression or an equation of a polynomial that has something to the power of 5 or something to the power of 6, just so that you are aware of how to use them. So we're going to look at number 1 here. Be sure to take these notes down in your own paper, and be prepared to ask questions or answer questions during this video while you watch on Edpuzzle. So here I have x to the 5th power minus x cubed minus 30x, and it's, if the directions here were to say to factor completely, I noticed here that there's not an equation, it's just an expression, so I'm just going to break it down as much as I possibly can. First thing I'm always going to ask myself is just, is there a GCF, just like any other factoring? And I see here that there is a GCF of x. So I could take an x out of all 3 of these terms. And if I divide an x out of x to the 5th, I have x to the 4th. If I take an x out of x cubed, I now have x squared. And if I take an x out of 30x, I have 30. So now that I've taken out a x out of the expression, I can focus on the insides, what I have left over. Now, we haven't dealt with anything to the 4th power, and we only have 3 terms, so I can't swoop and group from the inside, but I can think about the fact that this models just like a quadratic, but instead of x squared and x to the 1st power, it's x to the 4th power and x squared. I could pretend that this was just like x squared and x to the 1st power and factor as normal, but when I'm done, just substitute this back in. So what I'm going to do is leave this x on the outside. I'm going to treat this as a quadratic. So a is 1, b is -1, and c is -30. I would make my ACB chart, multiply, and b is -1, and my 2 magic numbers would be -6 and 5. Once I've got those, because a is equal to 1, I can just plug them right back into factored form here. Again, don't have to do swoop and group because a is 1, nothing else. So I would write -6 and plus 5. Normally, if this is a quadratic, I would need to get back to x squared, so I would write x times x, but instead this is x to the 4th power, so all I'm going to have to do is change this to be x squared and x squared. Then I would ask myself if I'm completely factored, because I've broken this down here, but I want to make sure I still have a quadratic in both of these binomials. I want to make sure that I couldn't factor this further. But I see here that this b term is missing for both of them, and -6 and +5 are not perfect square numbers. So if I use an ACB chart to factor this side here or this side here, it wouldn't be factorable. So in terms of factoring easily and breaking this down, this is as far as I can go for now with the skills that I currently know. So this is factored as much as I possibly can with the skills that I've so far known in Algebra 2. Moving on to number 2, I now see an actual equation. So I know that not only am I going to factor, but I'm going to actually solve for this polynomial, meaning at the end of this I should have something that says x equals something or x equals something else. I also see this is a degree of 6, which means that I should be looking for 6 solutions. I might not have all 6, some might be non-real numbers, but I should know that at the beginning I'm looking for 6. I also see there's 4 terms here instead of 3. So instead of, I'm first going to ask myself, of course, if there's a GCF, but I don't see anything. The coefficients are 1 and -4, and not all terms have an x involved, so I can't factor anything out. So I'm going to immediately start by swooping and grouping because I see there's 4 terms and I know I can break this up. I'm not sure if it's going to work, but I do know that if I get to a place where they match up after I factor by grouping, then I can continue. So I'm going to take this part here on the first side, ask myself what is the GCF. I see they both have x to the 4th power involved. So if I take x to the 4th power out, I then have only x squared from the x to the 6th plus 1, because that's completely gone. I'm going to ask myself the same thing over here. What's the GCF? Well, the GCF here is just -4. So if I take out a -4, I'm hoping that I get x squared plus 1 on the inside, which I do, because -4 over 4 is now just x squared. -4 over -4 is +1. And now I see that my 2 parenthesis sets match. So I have x to the fourth minus 4 as the outsides times x squared plus 1 equals 0. Now it says for me to solve for this, so I need to make sure that I actually continue. I see here that this is an x to the fourth, which is not quadratic, but just like this previous example over here, when it was x to the fourth power, I can treat it just like a quadratic. So I could make and ask myself, does this factor further? Well, if a was equal to 1, b here is missing, so it's 0, and c is negative 4. I make my ACB chart. 1 times negative 4 is negative 4, b is 0. I actually can factor this. Negative 2 times 2 and negative 2 plus 2 gets me negative 4 when I multiply and 0 when I add. So I can break this quadratic down into x squared minus 2, x squared plus 2, and then I still have x squared plus 1 over here equals 0. Now because this is all being multiplied together and it equals 0, I can start to use the zero product property for all 3 of these separate binomials. So if I set x squared minus 2 equal to 0, x squared plus 2 equal to 0, and x squared plus 1 equal to 0, and I can solve all 3. So I add 2 on both sides. X squared equals 2, square root, x equals the positive or negative square root of 2. So there are 2 of my 6 solutions. Then I go to the next equation. I subtract 2 on both sides. X squared equals negative 2, I square root, and now I've come to a problem because I can't square root a negative number. We know that that's a non-real number, so I know that I can, right now with the information I know with Algebra 2, I'm not talking about non-real solutions yet, so x squared I cannot take the square root of negative 2, that's not going to get me any more solutions. And the same thing is going to happen on this third equation. If I subtract 1 on both sides, x squared is going to equal negative 1, and if I try to square root both sides of that, I'm going to take the square root of a negative number again, and that is not going to get me a real solution. So right now, I actually can't get anything from this either. So now I only have 2 real solutions out of the 6, but I found 2, 4, 6 of them. I just know that 4 of them here are non-real answers. So x equals the positive or negative square root of 2 is all I can do from here. Our third and final problem that we're going to work through is factor completely this third expression here. It has a cubed. What I'm going to do immediately is notice there's 1, 2, 3, 4 terms. I'm going to ask myself, is there a GCF of all of these? Well, there is no GCF of 4 and 5 as a coefficient, so I can't divide anything out of all 4 terms. None of them all have an x, so I'm going to continue without taking anything out. I have 4 terms though, so I know that I can swoop and group. And I ask myself the GCF of each section. So the GCF here is x squared. The GCF here, the largest number that goes into 24 and 30, well, I can think about 30 has 30 and 1, 2 and 15, 3 and 10, 6 and 5. And 24 has 24 and 1, 2 and 12, 3 and 8, 4 and 6. So I can see that the GCF is probably 6. I would divide a 6 out. When I take x squared out of this first section, I have 4x minus 5. And when I take a 6 out of this second section, I have 4x minus 5. This is really good news because these two match. So now my 2 sets of factors are x squared plus 6 from the outsides and 4x minus 5. Because this here is 4x minus 5, that's as factored it's going to get. But I see an x squared over here, so I can see this is quadratic, so I have to make sure that if I can factor it, I would. A is 1, b is 0, c is positive 6. When I do my ACB chart here, 6 times 1 is 6, b is 0. There are no 2 numbers that multiply to 6 but add up to 0. So this is as factored as I can get right now. and I'm going to stop here. It does not tell me to solve, so I shouldn't actually be setting it equal to anything. This is as factored as I'm going to get. The purpose of these 3 examples were for just you to see, hey, I might not have been exposed to exactly how to factor something with x to the 5th or x to the 6th, but I have all of these tools that I've already learned, and I can use them even when it's not something that looks completely familiar.